this lesson, we're going to find the slope of lines, and we're going to work with them in terms of single lines and also comparing a couple lines to see if they're parallel or perpendicular. So first of all, these types of notes are called two-column notes. And so what I'd like you to do is draw a line across like this on your note page, and then draw a line down this way. That creates two columns where here you would have your topic, and over here you have your details of the notes. So try that. This is it's called the Cornell type of notes, and that will help you learn how to take notes. So when we look at the slope of a line equals rise over run, where the rise is how far you go up, which is positive, or down, that you go negative, and the run is where you go side to side. If you go to the right, it's positive, and to the left is negative. So let's talk about how we count the slope of a line on a graph. So if we look at this graph here, notice that it's illustrated that to go from one point to another, you go up 2 and over 3, up 2 and over 3. If I went from this one, I could go up 4 and over 6 to get to that point, and 4 over 6 still reduces down to 2/3. So my slope is 2 over 3, because that's how far I rise, go up, and run to the right for a positive for the slope. Okay, so for this one, let's count our slope. So for this, to go from here down to here, where the other point is, that's a run of going down 1, 2, 3, 4 units. And then we run over here. Notice that's going over 1, 2, 3, 4, 5 units, a positive 5. So our slope would be -4 over +5, or -4/5 for our slope. All right, now what happens though if we don't have any rise or if we don't have any run? So for instance, this example here, this has, all we do is we run. We have no rise. It doesn't go up to go to the next point. It just runs along. So if the rise is 0, then the run is any number. Like if I go from this point to this point, I run 2. Well, 0 over 2 is still 0. So my rise over run is 0. Every horizontal line has a slope of 0. So let's summarize that information. This is slope by direction. Positive slope is where you go uphill from left to right. If you think about it as a skier, the skier, if we're going from left to right, has to go uphill, maybe track their way up the hill as they go that way, so it's positive. Going up is positive. Negative slope is going down, so the skier would go downhill if we go from left to right. 0 slope is between these two. It's not going up, it's not going down, it's just horizontal. So horizontal lines look like this, that's our 0 slope. Whereas undefined slope, that's vertical. You can ski on a horizontal line, you just have to cross-country ski your way. But vertical, that's a cliff. You can't ski on it. There is no slope on that one. So notice the difference. 0 slope and undefined slope are not the same. Another way we say this is, we'll call this no slope. Okay? 0 is a number, it's horizontal, but no slope is vertical. You can't actually ski on it. So let's talk about how we use formulas to do this. Okay, so this is the general idea of the direction. Algebraic formula is if you're given 2 ordered pairs, x sub 1, y sub 1, and then also x sub 2, y sub 2. Remember, we've used this notation before. First x, first y, second x, second y. The formula for slope is where you take the difference of the y's, so y sub 2 minus y sub 1. Okay, and if I start with the y sub 2, I've got to start with the x sub 2, but the x's go on the bottom, the y's go on the top to find slope. So as an example, if I take 2 ordered pairs, if I take the ordered pair, I'll just do an example here. Take the ordered pair 3, 2, and then also the ordered pair of a second ordered pair, we do 5, 9. We do the difference of y's over difference of x's, so slope is going to equal 9 minus 2 over 5 minus 3. So difference of the y's over difference of the x's, that gives me 7 over 2 for my slope, as an example. That's how you do it algebraically. Now let's talk about the types of slopes we have. Okay, types of slopes, we're going to talk about parallel lines and perpendicular lines. These are actual theorems that we'll be using, okay? And the theorems are the theorem and its converse. So the conditional and its converse are both true. So we're going to write this as a biconditional. So two lines are parallel if and only if. Remember, that means it goes both ways. This could be the hypothesis or it could be the conclusion. If their slopes are the same, they're equal slopes. Okay? So what we say is we say parallel lines if and only if. Remember, that's a double arrow because it goes both ways. Well, we say then our slopes are equal. Okay. Now, perpendicular line theorem, what that tells us, let's go up a little bit here. Perpendicular line theorem says two lines are perpendicular if and only if, now this, we're going to use some technical math terms, their slopes are opposite reciprocals. Okay, there's some terms for you. Opposite meaning if one's positive, the other one's negative, or vice versa. Reciprocals means as a fraction, you flip it over. So we'll do some examples here in just a moment. But what we have is we say perpendicular if and only if slopes, this, we're going to write that out, slopes are opposite reciprocals. Okay, so just below here, let's remind ourselves of what that is, okay? So if I have, let's just define reciprocal first of all. Reciprocal is you flip the fraction. Okay, so if I have this, let's do some slopes. If I have a slope, what is the parallel slope and what's the perpendicular slope? Okay, so let's just do a couple examples. If I have a slope of 1/3, the parallel slope is just 1/3. It's the same. So two lines that are parallel would have the same slope. But perpendicular, I'm going to do the opposite, so make it a negative since it's positive, and then flip the fraction into 3/1, which we'll rewrite as just -3. So if we have, for instance, -4/5 as our slope, then the parallel slope is -4/5 of every line that's parallel to it. But the perpendicular, we take its opposite, so we're going to make it a positive, and we're going to flip the fraction, make it 5/4. Okay, so that's how you do parallel and perpendicular. Okay, so let's take a look now at some examples. We're going to find this. I want you to pause the video, take a few moments, and I'd like you to find the slope of each of these lines. Okay, and when you do that, what I'll do is I'll come back and I'll then work it out with you. So pause the video, try these 3 problems, and then come back in just a moment. Okay, now that you've tried it, let's go ahead and do this. If you look at this point here, which is 0, 4, what you do to get to the next point over here, you can just do rise over run. So we're going to go up, and notice that's up 1, 2, 3, 4 units, so positive 4. And then we're going to run, let's change this to a little bit smaller marking here. Run over here 2 units. So the rise over the run is going to be slope equals 4 over 2, which equals 2. You can reduce that down to just 2 over 1, which is just 2. This one here, to find the slope, we're going to, you can do it between any points. I'm going to pick this point and go all the way down to that one. So if I rise, I'm going down here. So I go down 1, 2, 3, 4, 5, 6 units, so negative 6. And then I'm going to run over. Notice that's a positive 3 units. So my slope here is going to be the rise, which is negative 6, over the run, which is positive 3, which gives me a negative 2 for the slope. And then this last one, this is a vertical line. Notice that there is only rise to this one. If I go from this point up to that point, I rise 1, I don't run anywhere. That would be rise over run would be 1 over 0. You're not allowed to have 0 in the denominator. Not allowed. Okay? Dividing by 0 doesn't work. You can try it, it doesn't work. So that means we have no slope, or we also call that undefined slope. Know it by both terms. Okay? Undefined slope. Okay, so vertical lines are no slope or undefined slope. All right, let's look down here. We want to graph the points and draw the line through those points, okay? Then we're going to find the slope of the line through the points parallel to it and perpendicular to it. So let's plot these 2 points here. I'm going to do it in purple here. So negative 3, 1, this is my x and this is my y, right? Let's go a little bit smaller here. Okay, now I'm going to start with negative 3 for the x and then 1 for the y. So this is negative 3, 1. Okay, the next one is 2, 3. So let's go over 2 and up to 3 here. Now that's not my slope, that's the ordered pair, 2/3. Okay, that is a line. If I draw a line through this, it looks like this. And I can find the slope of that. I can either, I'm going to do it, I could do it from the graph. I'm going to do it using the algebraic formula that we talked about on the previous side. So the slope is going to equal difference of the y's, so 3 minus 1, over difference of the x's, 2 minus negative 3. 3 minus 1 is equal to 2. And 2 minus a negative is 2 plus 3, which becomes 5. So my slope is just 2/5. So every parallel slope will be 2/5 of every line parallel to it. Perpendicular, I take the opposite and I flip the fraction and make it 5/2. That's my perpendicular slope. All right, so let's have you try this one. This is page 185, number 8. I'd like you to go ahead and plot these points. And then what we're going to do is I'd like you to find the slopes of each of the sides of it. Okay, so from one to the other. So plot the points, connect them. It's going to be a quadrilateral, and then find the slopes of the sides. Do that, and then we'll come back to me and we'll do it together. Now that you've tried that, let's go ahead and plot it. Okay, so L is, let's change colors here. L is negative 2, 2, so negative 2 and up 2 is right there. So this is L, negative 2, 2. M is 2, 5, 1, 2, 3, 4, 5. So M up here is 2, 5. Make little smaller. All right, and let's do n is 0, 2. So that's going to be right here. So n is 0, 2. And p is 3, negative 2. So 3, negative 2 takes me right there. So we plotted all those points. Okay? Now we could connect them with different lines and find the slope. So if I connected these two, draw a line here, notice that my slope would be, for this, would be negative 2 minus 5. So if I would rise up here from 2 to 5, I go up 3 units. So my slope equals a positive 3. And then I'm going to run over from this one to that one. I go over 1, 2, 3, 4 units. So my slope of that line is equal to 3/4. Now let's try this one. Let's connect these guys. Connect it with a different color. Okay. So this one, I would rise from my slope. I go down 1, 2, 3, 4. So that's a negative 4 for the rise. And then I'm going to run over from here to over here is 1, 2, 3, 4. Oops. So to this point, sorry. So down 1, 2, 3, 4, and over 1, 2, 3 units. So negative 4/3. Now, if you look at these two fractions, okay, that's a negative 4/3 there. 3/4 and negative 4/3, they are opposite reciprocals. These two lines are perpendicular because they're opposite reciprocals. So what we've learned is as we work through slope, you find slope by either on the graph, measuring rise over run and knowing which is positive up, negative down for rise, and if we go to the right, it's positive for the run, and left is negative. Or you could do it using the formula, which is the difference of the y's over difference of the x's, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You could find slope. If your lines are parallel, the slopes will be exactly the same, equal. And if they're perpendicular, they'll be opposite reciprocals, where you take the opposite and flip the fraction to get the new slope. And that's a summary of how we use slope in these problems.